On behalf of Physics Made Easy Kota, we come with a new video lecture on the chapter Atoms and Nuclei. First of all, we are going to discuss J.J. Thomson model of atom. We all know that atoms are the building block of matter. They consist of the three basic particles, electrons, protons, and the neutrons. And the first model of atom was proposed by J.J. Thomson. The discovery of the electron, that is a negatively charged particle, by J.J. Thomson led him to propose the structure of atom. Watermelon is a fruit that all we like to eat, and Thomson compared the model of atom with the examples such as he compared its model with the watermelon. He also compared his model with the plum pudding. So according to his model, each atom consists of negatively charged particle called electrons. This is clearly observed in the atom model in this figure. So and we know that atom as a whole is a neutral. So there must be the positively charged particles in the atom such that the net charge on the atom is 0 and atom remain neutral. So there are the positively charged particles, and these positively charged particles have uniformly spread and they are of the uniform density, in which the negative charges, that is electrons, are embedded, just like the seeds are embedded in the watermelon fruit. And he also compared its model with the plum pudding model, so it's sometimes also known as the plum pudding model. Thomson also assumed that the harmonic oscillation of the electrons about their mean position caused the emission of the light. He also predicted that if a beam of alpha particle passes through an atom, it suffers only a small deflection due to weak electric forces exerted on it by positive charges. But along with this, there are some limitations of Thomson model. First of all, Rutherford, who is a student of J.J. Thomson, proved that the positive charges were not uniformly distributed in a sphere as suggested by Thomson. Thomson model could not explain the presence of discrete spectral lines emitted by hydrogen and other atoms. Also, this model could not explain the large angle scattering of alpha particles when incident on a thin metallic foil, we can say that on a gold foil. Hence, efforts were made to look for a better model of atom. Rutherford and his associates studied the alpha particle scattering by thin gold foil to suggest a new model of atom. He conducted an experiment by bombarding a thin sheet of gold with alpha particles and then studied the trajectory of these particles after their interaction with the gold foil. Rutherford performed a series of experiments on the scattering of alpha particle due to atoms of thin gold foil. So the question arises, what is alpha particle? An alpha particle, that is also denoted by He raised to power 2 positive, is a helium atom from which 2 electron strains are removed. Thus, charge on alpha particle is plus 2e and mass of alpha particle is nearly 4 times the mass of the proton. So this is the basic experimental setup by Rutherford and his associate. It consists of source of alpha particle obtained from a radioactive substance, and the narrow beam of alpha particle was made to fall on a thin gold foil which is of the thickness 10 raised to power minus 8 meter. A circular screen coated with zinc sulfide was kept in such a way that it received the beam of alpha particles after passing through the thin gold foil. Alpha particles scattering in different directions were observed with the help of movable detector. When a beam of alpha particles are scattered by thin gold foil, these scattered alpha particles fall on a fluorescent screen and small flashes of lights are produced. Then these are observed through the movable detector. But some precautions must be here, that this experiment was conducted inside a evacuator chamber to avoid the scattering of alpha particles due to atoms of the air. Rutherford and his associate made the following observation from the scattering experiment. The first one, that the most of alpha particles pass through the gold foil undeflector. It is shown by the path A. It means that most of an atom is an empty space. Some of the alpha particles were deflected through small angle as shown in path B, and for the path number C, that few alpha particles were deflected through large angle, and some of them even retrace their path, that is the angle of deflection was 180 degree. So these observations are given by the Rutherford from his scattering experiment. Also, the alpha particle is positively charged and having large mass as compared to the electron could only be deflected backward by some large repulsive forces. So Rutherford concludes that the positively charges in an atom were concentrated in a very small region at the center of the atom, and this region is known as the nucleus. That's why the path number C is formed in this experiment. Path followed by alpha particle in the electrostatic field of target nucleus depend upon the collision parameter, which is also known as the impact parameter. So what is impact parameter? So we can see that from the figure that impact parameter is a perpendicular distance between the center of the nucleus and the direction of the velocity vector of alpha particle when the force of interaction is minimum between the nucleus and alpha particle. Here you can also observe the angle theta, which is known as the scattering angle. So this is the angle between the direction of approach of alpha particle and the direction of scattered alpha particle. Next important topic is distance of closest approach. This is called as the minimum distance. The minimum distance of a point from the nucleus up to which an energetic alpha particle traveling directly towards the nucleus can move just before coming rest and then retracing its path. Rutherford gave its best to explain the structure of atom, but here are some limitations. It failed to explain the stability of the atom. According to him, electrons revolve around the nucleus in a circular path. Anything which moves in a circular path is accelerated towards the center of the circular path and has centripetal acceleration. Thus, electrons revolving around the nucleus are accelerating towards the nucleus of the atom. According to classical electrodynamics, any charged particle while accelerating or retarding loses energy through electromagnetic radiations. Therefore, the electrons revolving around the nucleus must lose energy continuously. As a result of this, the radius of the path of the electron goes on decreasing, and ultimately a stage comes that it should fall into the nucleus by following a spiral path. But it never gonna happens, as atom should not collapse. The electron keep on revolving around the nucleus without falling into it. Rutherford could not explain this fact. Hence, Rutherford failed to explain the stability of the atom. There are some questions related to the Rutherford model of atom. How was the Rutherford model formed? It was formed by the scientist Ernest Rutherford. What is an alpha particle? We already studied that alpha particles are the nucleus of the helium atom. It has a charge +2. The fast moving alpha particle has a good amount of energy. Why did Rutherford use a gold foil? Because he wanted as thin a layer as possible, and the gold foil was about 1000 atom thick. Thank you for watching. Take care. Have a nice day.